Hi guys, καλησπέρα παιδιά. My name is Eleni and I welcome you to the fifth event of our team with title Introduction to DevOps. Today the event will be in English because we are honored to have with us Kai Hendry, who is a professional DevOps engineer and also a YouTuber. So our team member Yannis, with the help of Kai, will tell you all the basic things you have to know about DevOps. As always, if you have any questions, you can comment in the chat and we will answer all of them at the end of the presentation. So that's all from me, and we are ready to welcome Yannis.
Καλησπέρα, Eleni. Thank you for the introduction. Time appropriate greetings to everyone. I hope you're all doing fine. Today's event is going to be about DevOps, but first a little bit about myself, since this is the first time I'm presenting to you. I'm going to be making talks about DevOps, a bit of system administration, and a bit of Linux. I'm a sixth-year student of economic science in Athens University of Economics and Business. And today I'm having to present a pre-recorded show because Kai lives in Singapore, so the time difference between Greece and Singapore isn't really optimal for live shows. But first, a bit about DevOps. Who needs to learn about DevOps? Well, actually, if you are a web developer, or either front-end or back-end, you should know a little about DevOps because you're going to learn about best practices, how to more efficiently work on your projects, and how to be more consistent on your updates. Now, for the next 50 minutes, I'm going to leave you to the pre-recorded show, and I hope you all enjoy it. See you then. Bye. Hello, Kai.
Hello.
Kai is a YouTuber and he's a DevOps engineer. I don't know which comes first. Kai, what do you think?
I'm trying to be influential, actually, because DevOps is pretty boring.
Okay, that's a good way to start a presentation about DevOps. So how did you get into DevOps?
I guess I've enjoyed running a free operating system called Linux, and over the years Linux has become the sort of de facto server operating system too. And since I've been running Linux day to day for so long, the skills are needed on the server commercial space. So people pay for my time to help them maintain their servers and infrastructure. So that's how I got into DevOps. Of course, the name DevOps is just a term nowadays to describe, modern day system administrators like myself.
I see. Well, I have almost the same story. I started using Linux about 2.5 years ago in summer 2018. And at some point, I started learning system administration without even knowing it's a job. Like it felt fun to learn about that stuff. It was so fun that I skipped a couple of semesters in my university because I studied economics and it didn't feel as fun as that at the time.
I mean, I hope you were doing something with the computer that made it fun, playing games or I don't know.
Actually, yeah, I came into Linux just before Proton came up from Valve, so I could play almost any Steam game I wanted.
Yeah.
Anyway, let's get into our subject. What is DevOps? I hear it's about system administration and development together. I mean, how does this work?
Yeah, I think DevOps, as I mentioned on a couple of videos, I think it falls into it's a broad range of things. I think most people think, some people say DevOps is like a culture, like being embracing continuous delivery, and that sort of just means like a modern day version of the Japanese Kaizen approach, I think it was called. My name's Kai, and Kaizen is an approach I'm taking after. The whole Kaizen approach is, I think you'll learn about it in like some industrial revolution that happened in the Japanese economy. The whole idea with the Kaizen approach is that you're delivering continuously and you're being agile and adapting your process. So I think DevOps is about embracing that sort of continuous delivery And that means making changes to your deployment workflow instead of like having like a release party, having a ceremony for a big, 1.0, 2.0 release. You're delivering daily, more than once a day sometimes, if that's where you want to get to. That's how I think of DevOps lately. Continuous delivery.
One other great thing that I've seen people talk about is that when you update a web page, for example, whenever the user clicks refresh, he gets instantly the new page. No downtime, no wait 15 minutes for our servers to restart.
Yeah,
everything happens instantly.
Yeah, that's the beautiful thing about the web, is that the upgrade path is pretty much perfect. You can improve on the experience every day. But unfortunately, these modern day things like single page application SPA, they've unfortunately broken the web to some extent. But I think the web is still the best at being able to afford a seamless update path. And that's what you want, right? You want it to be seamless and not painful to update all the time, and offer a better value to your customer.
So if I get this right, we've got a load balancer in front of our servers, and whenever we want to update our website, we just switch the load balancer to the new nodes, and it starts pointing to the updated web server, right? That's
correct. I mean, in the good old days, you could just restart a service with in less than a few milliseconds, and of course, you're basically you don't need a load balancer then, right? Because you can afford for a request to be delayed or something like this. But a load balancer is probably the safest way of making sure you don't drop a request. But I think the web is pretty fault tolerant when you do drop a request. But yeah, the professional way to do it is use a load balancer. Use something like AWS ELB or something like this. But in modern day infrastructure, in the serverless world, there's this thing called API gateway, and that does the sort of blue-green. It's called not dropping a request while you update. In this industry, it's bizarrely called blue-green or something like that, and the API gateway implements that basically.
All right, we're going to talk about serverless in a bit. We've already touched on continuous integration and continuous delivery, how that works. The next point in what is DevOps in the Amazon's AWS page is microservices. Can you talk a little bit about microservices and why you don't use them?
Unfortunately, I've been burnt by microservices, so I don't have many good things to say about microservices. But the idea, I think, with microservices is that you, and I can share a blog post about my thoughts and extent, but the idea with microservices is that you have these little applications do one thing well. Sounds good on paper, it's like the Unix philosophy or something like this. But in reality, there's a lot of communication overhead. There's a lot of problems like tracking the requests through microservices. There's a lot of pain. So I don't really recommend microservices. I know Amazon promote the use of microservices, but I'm going to be a bit contrarian and say to you that don't just have a monolith. Just have a Go application that implements several things. Your application. You don't need to split it up.
All right. I think send me the link so we can link it on the description of the video. Right now, everyone can go read it in the description.
So yeah, don't go for every little. There's always going to be some hype thing in DevOps or computer stuff. Just be a bit critical, as I suggest, or go into it like I did and just feel like an idiot afterwards.
All right. Okay. Well, we have to say that microservices is the preferred way in a lot of industries. So take everything you read with a grain of salt.
Yeah.
Okay.
Please do.
Let's get to the next subject that I think you agree with. Infrastructure as code. How does this work exactly? Can you explain it?
infrastructure as code is basically the code being hopefully the code is basically describing what you want your infrastructure to look like. So, what is infrastructure? It's some servers in some data center somewhere. So say you need storage for, a few movies. So you need like a 5 terabyte drive. You need, maybe you need some compute power in order to sort of transcode it so you can watch it on all your devices or something. So you need a CPU. And so the infrastructure code for that sort of setup is something like, I need 5 terabytes of storage and I need 1 CPU. And that's essentially what it is. Unfortunately, it's got a lot more complicated with that, but different syntaxes and things like this. But you basically say to AWS or your public cloud provider of choice, Microsoft, Google, you say, I want this stuff. So that's basically infrastructure as code. You're declaring a particular state that you want. And I suggest that you use a declarative language for that. Don't use an open-ended language like the CDK. Just keep it simple. Just say, I want 5 terabytes and I want 1 CPU. That's infrastructure as code. It's that simple, really.
All right. But okay, quick question. What do you use for infrastructure as code? Do you use something like Terraform, which is cloud agnostic to the cloud agnostic? Okay, it's not exactly agnostic. I stopped midway because I've seen it on your video that it's not. Like every different service has a different
because
syntax.
The trouble with Terraform, it's not declarative, unfortunately. The syntax changes, the DSL changes. That sucks about it. And essentially, like when you work with Terraform, you have to say, I want 5 terabytes on AWS and I want 1 CPU on AWS. You can't, it doesn't actually abstract anything away. You have to if you want to use that same recipe on Azure or Google Cloud, you have to rewrite it effectively. It's a different sort of language. It doesn't really save a lot of time. The only thing I think it might be good at is that the language stays the same, because CloudFormation, the syntax in CloudFormation isn't quite the same in Google and Azure. So the language looks the same, but essentially the names are different. So I don't think it buys me a lot of value. So I'm not a huge fan of Terraform. It does have other features like tracking the state and the plan a little bit better. But in my opinion, just keep it simple. Just use the lower layer instead of the abstract Terraform layer. Use CloudFormation with AWS.
Okay. I don't know if you've used Terraform enough to know that, but and I've never used it. But Ansible has a couple of tricks to add some logic in your configuration and say, if I'm on AWS, do this. If I'm on Google, do this. And it can run some checks before running a block of
yeah, I'm sure you could probably write something like that in Terraform, but it's ugly in my opinion. I just rather
all right.
I'd rather just lose that logic and just keep it. I just want to, when I write my infrastructure as code, I just want to describe the state. I hate it when there's an if, there's a conditional. Like
exactly.
This is why this is why I like serverless, is because you don't have to say, I want a dev with 2 CPUs and I want a staging with 3 CPUs and I want a production with 10 CPUs. You don't have to do that. And that's what you want to go for. I mean, that's the thing. That's the key, I hope, takeaway. Strive for simplicity. That's the key.
All right. The next one isn't as simple as the rest, I think, when it comes to using it, but modern logging. Many people suggest using an elk stack. We're going to get into that in future.
The elk stack.
Yes, and something like NEM, and something like Nagios. If you have virtual machines instead of going serverless. So, how do you go about that?
For monitoring, okay, like Nagios is a bit old school, and I'm sure it works just fine. But you know, I think it's written in Perl or something. It's a bit antiquated technology.
Yeah.
I mean, there's always something new around the corner. It doesn't matter what tool you use, but like I use Prometheus for monitoring. I think it's pretty flexible, nice to work with. The Elk stack, again, it's just a tool, and I find it quite heavyweight. I don't really like it. I mean, I'm a suckless user. I don't like, you know, KDE. I use DWM. I strive for less code. I find the Elk stack, it probably serves some people just fine, but I find it very heavy, and I just don't like it. I prefer simpler methods to organize my logs. In fact, I just prefer to offload the logs to AWS CloudWatch, to be honest, as I'm lazy.
All right. So in a way, you've already described us how you go about each specific task in your day job. But can you give us a better understanding of what you do when you start on with a new client, for example? Let's say
a new what? Sorry.
A new client.
Oh, okay. I go make the client's name and a CD into that directory. And well, a new client. To be honest, I'll set up an AWS account, and I'll use an AWS account as I'll set up an AWS account, make sure their credit card is attached to it, and then I'll set up, you know, AWS CLI so that it's communicating that my local computer and my local client is communicating with the paid resources of that client. And I also very typically set up SSO. Anyway, this
what is SSO?
Single sign-on, and maybe I'll set up like some IAM roles, like for administrator for me. I don't really have a template or anything that I start off with. I just keep things as minimal as possible. I know a lot of my colleagues, almost, I dare say, would set up like a multi-organizational template or something like this with some VPCs or something like this. I just try rock with the defaults as much as possible, and then from there I would aim to hopefully set up a serverless environment with an S3 bucket or something. You know, that's typically how I would go about doing the infrastructure for a client.
Do people actually want you to change their system when they commit system, like with GitHub Actions and auto merges or anything similar to that, or you just help them with the infrastructure?
Well, for this infrastructure, okay, for code management, yeah, I like GitHub. I think it's the nicest thing to use. But of course, most clients are using some sort of crazy, you know, Atlassian or GitLab, or there's so many out there. But essentially, it's all Git, so it's not too much to get stressed out about. I use whatever the client likes. Unfortunately, in my line of work, you generally like picking up the pieces of a previous legacy project, and they're all trying to be consistent, so they don't want you to do anything new. So unfortunately, you have to use their tools to the most part. But personally speaking, I would just use GitHub because I think it's very nice to work with.
All right, I think we covered in general what DevOps is. We're gonna see more about that in future events.
Oh, I don't think I mean, maybe I should talk a little bit more about CI part, because that seems to be like the buzzword, CI/CD.
Okay, let's talk about it. I wanted to leave it for the Q&A in the end, but I think we can cover it now. I'm sure we're gonna have a couple of questions. I've heard people trying to say that we only do CD in my company, and I'm like, how do you do continuous delivery without continuous integration? How do you deliver without any new updates? How does this work exactly? So let's talk about it for a minute. Yeah.
CI/CD. Okay, I mean, don't be pedantic about these different words. I mean, I say CD because I don't like to say CI/CD. I feel like an idiot when I say CI/CD. Can we just say CD? Because CD incorporates continuous integration.
Okay.
You need to incorporate continuous integration to have continuous delivery. So we can drop CI, I think. But of course, if you Google around, everyone's talking about CI/CD. Maybe it's because if you search for CD, God knows what you're going to get. So they just prefixed it with a CI or something like that. It's one of those problems. But yeah, like typically what continuous delivery means in practical coding terms is that you code like a GitHub action or Travis CI.yaml or a GitLab YAML, and you're basically describing the steps of how to recreate the environment for which your code is set up and built and things like this. And my big ask of you is that don't make it complicated, make it fast, because every CI or CD, whatever I come across that takes it longer than a couple of minutes to run, it breaks my heart. It makes me cry, because I don't want to waste my lifetime watching a build. I want it to be quick, and I want to iterate quickly. That's another big part of continuous delivery. Be quick, fast iterations. A slow build, a slow deployment, it's problematic, and you need to track it. Just take your phone out, click start and stop on your stopwatch, track how long it takes, and aim to get that smaller and smaller and smaller. Because the faster you can move with your continuous delivery, the faster you can deliver, value to your customers and make more money and retire early to the beach. That's what I think.
All right, I'm gonna show in action what GitHub Actions look like. Sorry for the pun. Okay, I'm gonna try to find either a project or I'm gonna build a new one from start. Something in Rust or something. What? No, it's gonna be very simple.
Oh, we're gonna code simple right now. We're gonna.
No. I'm gonna do it. I'm gonna do it in my own time, and I'm gonna upload it in the GitHub. We are gonna make a GitHub for the whole organization.
Okay.
All right. I think we covered it. Actually, the first time that I saw what GitHub Actions look like was when I tried to commit in the Flatpak repository. Sorry. The Flatpak repository, and I saw a couple of bars trying to check for. I think they had the linter built in, and they tried to see if the package was still able to build. And since I only added documentation, I think it didn't check for that, but it was quite fast.
Okay. Well, I've been struggling with GitHub Action today, and it really sucks. Because the big problem with CI and CD systems is it's very difficult to recreate, test that it's very difficult to, that's the big problem with DevOps. It's difficult to recreate, to test the infrastructure as code on your own computer. It's very difficult to test the CD, the GitHub workflow on your own computer. So inevitably what happens is that I push my workflow changes to GitHub. I sit around for 5 minutes watching it build and fail, and then I go on and go, and then before I know it, lunchtime arrives, and then the rest of and I've hardly got anything done. So the iteration cycle is pretty crappy. There are tools, I think, called GitHub Act or something like that, where you can try run the workflow locally before pushing it. But in my opinion, it's just broken. I tried it today again, and it sucks. So that's the big problem with DevOps, is that you're working with the cloud, and it can be very slow at times. And it shouldn't suck so bad, but it does right now. Hopefully it'll get better.
All right. I don't know how much time we've got left. We should have tracked that. Anyway, let's say how can anyone start learning about DevOps? Since I'm the beginner here, I should say that I started learning about it without even knowing, by learning how to use Linux. If you start developing your applications in Linux, you're going to find ways to automatically build your application with every new addition. You're going to learn how to properly use the command line, and how you're going to discover new technologies that you're not able to use in Windows or maybe even Mac. I think you can use most of them in Mac. For example, I recently found out that Ansible is a much better idea. It's a much better tool to use to automate things rather than bash scripts. And trust me, I've spent a lot of time working on bash scripts to automate installations.
Yeah, well, I mean, I don't use Ansible or Chef anymore. I think CloudFormation supplants all that stuff. But yeah, like there's a whole bunch of ways to get started, I guess. For me, I like to have fun with my friends, and I think the first reason why I got Linux running is to run a Quake server. Okay, fast forward into 2020. I had flashbacks to that same experience because I set up a computer for my son, and I set up a Minecraft server. So you can download Minecraft Bedrock server and run it on your LAN. And then when you download a tarball and you extract it, put it in the right place, set up the service file, the init service file. Anyway, you just going about running a server reliably that your friends use and have fun on, you'll be learning DevOps. Most of the DevOps skills that you'll need in the industry, really. You'll be learning how to look at your logs when something goes wrong. You'll be learning how to update that software without overly, kicking your friends off the server and upsetting them. You'll be learning these things slowly but surely, just by doing something fun, I like to think.
How about some more hands-on stuff that has to do with DevOps? Let's say someone is an experienced Linux user and he's been working on his own projects and he wants to get into DevOps to automate some of his stuff. Besides reading the docs about GitHub Actions or a couple of other sources, what other things or certifications can someone get for DevOps?
Certifications?
I would suggest a couple of good ones from Google and Amazon. Maybe you could go into Google's page on Coursera. They've got a couple of good courses there. I've checked out the free ones. Do you have anything else to suggest?
Well, when I first got started, I joined the Debian community and I strive to become a Debian developer, which is not easy. But I feel I actually didn't officially get a Debian developer label. I was like a Debian maintainer or something. But I think that is the best experience. That ramped up my skills. Contributing to an open source project, closing bugs, filing bugs. Yeah, I mean, don't expect to fix bugs or close them, but help triaging them. Like organizing them. I think that's the best experience about you can do to get yourself prepared for the commercial world, if you know what I mean. Just contribute to an open source project. I don't think any Linux or AWS certificate is really needed, but it certainly might help you. It depends how whatever you think feels right, or just give it a try, right? Whatever.
All right. One more question. What kind of programming languages do you use in your day-to-day job?
I would say Bash is probably the most important. Shell is the most important because Shell is the essential language of most operating systems. It's the way of bootstrapping things. With here docs. It's just a way. It's actually blazing fast, and it's an incredibly useful language. So I would recommend starting with Bash and just learn it. Like have a little project, write an image gallery or something like that. You'll pick it up, I'm sure.
In order
And
to learn Bash, I automated Arch Linux installation.
oh yeah,
Took me
automate
months, but
yeah, I think Bash, it's a great little language. And so yeah, Bash is the most important. POSIX shell. Um, and then what else? I mean, nowadays, unfortunately, guys, you got to learn like several languages. So JavaScript is probably next. Golang, and that is a great systems language, not for scripting, but for doing things properly. Go. Don't be afraid of C. I mean, C essentially is what Linux is written in, and just it might seem overwhelming at first, but just pick off something easy and small, and just learn about make is an important tool. Learn make. It's so fundamental. Every project should have a make file.
for those who don't know, make, if you use Windows, you may not have seen enough make files. If you use Linux and you try to install anything that is outside of the main repositories, you're gonna see a make file, and you're gonna use make, and you're gonna see how it works. So that's why we both suggest you use Linux. I've been using it for 2.5 years, and I can even game on it. Like I can game right now because I don't have a graphics card, but you can game with most of Steam's games. Okay, you can play League of Legends, but I wouldn't play League of Legends even on Windows because they now started using a kernel level anti-cheat.
Okay,
and that gives
sucks.
them, that gives them kernel access to your system. So,
but importantly, I think
trust them competence anyway.
One thing I missed out. I mean, having fun on Linux is one thing. Having access to the code so that you can manipulate things, you can learn deeper in things about it, gain deeper insights. But I think that the fundamental reason why I really enjoy Linux and this computing environment is just the freedom. If every company on this planet hated me for one reason or another, pulled the plug on Microsoft revoked the license, and Google threw me off Gmail for complaining too much, I can always go back to Linux and install things. And since I kind of fundamentally know how the whole operating system works, in fact, I wrote my own operating system called Web Converger. Since I know how an operating system is built up, I feel empowered, I feel confident just because I know how fundamentally most things work. And that's a great feeling, because when you talk to your parents or some people, that I can see that they're just overwhelmed by computers, right? But I know how they work, kind of. So I feel great about it, and I feel free. I don't feel bogged down by whatever Google's going to do to be next, or whatever how Apple's going to change its UI or something. I don't feel stressed out about it at all, because I know how to live free.
All right. The last things that I have in my list to talk about are vendor lock-in, because
living free with vendor lock-in.
Last week when we talked about it, you said you're prepared to move to a new cloud if you have to.
Yeah.
What happens now that you have to change all of your applications to work with Lambda, AWS Lambda? Are you gonna do it?
Well, I have like a proxy or something like that. I have tools to proxy my web requests. So the fundamental standard is the HTTP request and response interface. Mm-hmm. Just remember that is the open standard, defined by IETF and the WAT workgroup. HTTP. So this is the standard interface that I make sure all my applications adhere to. And then, of course, since AWS has their own interface, you have to translate that HTTP interface into Lambda. And I have like Apex Gateway, I have Node serverless or something like that helps me convert a standard web application that can run locally on my machine for the Lambda or whatever serverless environment that I'm targeting. So there's ways around it. So you just got to keep that in mind, but always adhere as a principle to HTTP.
So if I get it right, you are using AWS specific functions that are supposed to lock you in to their platform, but you are doing it in a way that you will be able to move out if you have to.
Correct. So since my application is essentially an HTTP interface, I can just put it into Azure or put it into Google Cloud Run or something like that. It's I haven't got. I'm actually working on an example where I'll demonstrate that is really the case. I mean, I've got started, but I haven't quite finished it because, signing up for these different clouds and all that stuff, it's a bit boring. But I'm confident that I can do it.
I think that people then should subscribe to your channel. It's Kai Henry. You can see the name on the screen. Just don't put the... Well, if you search on YouTube Kai Henry, you're going to find him. He's going to be the first result. He's got a lot of interesting videos.
Thanks.
So I'll be waiting for the video you're talking about right now.
Well, the one where, okay, fine. Yeah, I'll figure that out. Yeah. Yeah. But I did kind of skip again. I mean, one fundamental problem is that if you manage to get the compute running on different public clouds, you're going to have probably a problem with the database. But again, you can use SQL. Don't use maybe DynamoDB. You can use SQL, or you can just use flat file formats like CSV or maybe even SQLite. So I think it's, yeah, I have the confidence to move my application around different public clouds, and you should too. Yeah, I think that's a good exercise for anyone who wants to become a DevOps engineer. Get Hello World working on 3 different public clouds.
All right. Okay. What about Kubernetes and Docker? Let's forget for a minute that the two are not going to be compatible in a couple of months.
And Docker. Oh yeah. I hate Kubernetes with a passion. Hate it. Yeah. Once upon a time, Google invented this, crazy over-engineered system, and then they dumped it on the world. That's the thing with open source, is that like when a company XYZ says like, oh, we are open sourcing something, maybe that application sucked so hard that they don't want to support it internally and they want to dump it on the open source community. I feel that way about Kubernetes.
It actually comes from the Greek word Kubernetes, which means captain.
Oh,
I don't know if you knew that.
I'm sorry that they bastardized your language to support their product name, whatever.
I mean,
no, but
Kubernetes is not that hard. I don't know how to pronounce Kubernetes properly. Is it Kubernetes?
Yeah.
Is it Kubernetes?
When I write it, I usually just have K8S or something, whatever. But I find it too complex, far too complex. It's microservices all over again. And, there's always like some weird certificate problem or something going on with it. It's just a nightmare. It creates jobs, it creates work, and that's just unnecessary. Like there's a lot of things in this industry, I feel, that just creates needless wastage. It creates jobs, but it's just pointless.
Right. I have to say that for our viewers, if you want to get into DevOps in Greece, you have to learn how to use both Docker and Kubernetes, because most job applications are gonna ask you to know both of them. So
well,
maybe add it in your resume, but suggest them a different approach.
Yeah, maybe put like hate Kubernetes or something. Well,
I didn't say that. I didn't say that.
I mean, whatever. Yeah, I mean, you need to learn Docker, I guess. I hate Docker, but like that's kind of necessary evil. It's probably the easiest way to get like things running on different people's computers. But
what about Containerd or Podman from Red Hat?
I think they're just forks of Docker maintained by different companies.
Containerd is what Docker uses. Docker is
And I think
the
it's
higher
linked,
level front end.
yeah. I think the games that they're playing are like, you know, different. They're trying to like put the technology into different holding companies. I mean, I wouldn't pay much attention to it. These names are going to change, and they're going to change again, and just don't get stressed out about it. But essentially, yeah, Docker is a kind of a useful technology, but it has a lot of drawbacks, which I don't like. You know, the fact that an image isn't like a straight up file, the fact that you have to put an image into a particular, you know, repository instead of having a binary file on your file system, that kills me.
Or even an ISO or something. Something that feels like you can move it around. A Docker image, you can't back it up. You have to shut down and back up the config file.
And let's not forget that Docker images are quite slow. So like, the minute you want to like push an image and get it up and running, it does take a few seconds. It shouldn't be that way. It should map to memory cleanly and get your application running in like a zillisecond. I just made that up, by the way. But I find it quite slow. And like most people, I mean, the layers and all that stuff, most people don't really use them properly. So whatever. But yes, I don't want to sound too negative or something like that. But you need to be critical. You need to have a critical, you gotta, it's fun, you know, like most things require a bit of a debate or critical thinking, and especially this industry.
Although Docker has a very nice advantage, it's the only thing that you can run locally. You can't run an AWS instance locally. I mean, you can. I think Amazon offers that now. I think I saw that in the presentation recently.
No,
you have to pay.
Their Lambda Docker images are not easy to run locally. But yeah, I mean, Docker is kind of easy to run locally. Yeah.
So it's the only thing that you can practice for free. You can practice with for free.
Yeah, it's a way of getting things running locally. Yeah, I mean, but I wouldn't. It's not the only way. Like, there's this thing called static binaries. You could use those instead. But you know, most people don't know about them.
What if you're using Python or Java?
Then you should switch languages immediately to something that can support static binaries.
Okay.
I mean, I think there are ways of wrapping up Python and Java, for that matter, so that they're just like basically one ball or something like that. You know, you essentially like. I think the way I explained it to somebody recently is like, for example, a movie. A movie has a soundtrack. A movie has subtitles. You know, what is a nicer way to distribute a movie with 3 different components? No, you want one thing. You want one thing. You want to send that movie to somebody so that that person can watch it with or without subtitles in a different language. You want the whole bundle in one file. That's just common sense, really.
All right, but I've learned from you that even Go isn't completely static when you build a binary.
Golang. Yeah.
Even Rust. I mean, Rust can compile to a single file, but it still uses glibc on Linux.
Well, there are ways to make it more static binary, like CGO enabled being disabled or something like that. There are ways to make it more static. I mean, unfortunately, there are people who think static binaries are bloated. You know, they think that like a 20 megabyte
Please don't use that
file,
word with me.
Yeah, some people think that a static binary being 20 megabytes is a terrible thing, and they'd rather have a dynamically linked binary, which would obviously be a lot smaller because it's linking other dependencies. But yeah, I mean, come on, be sensible. Having that one file that has all the dependencies in it makes it much easier to distribute, and you know, much easier to find like 10 years later. Like, I want to be able to like pick up a binary and be able to run it from 10 years ago without having to recreate the whole environment.
Exactly, and then you don't have to get things and you don't have to get things like app image or flatpaks or snaps.
Yeah. I mean, all these containerd, flatpak, containery type things. My other complaint, which I mentioned in one of my YouTube videos, is that the APIs that all these containery things require is also pretty unstable. It's very unstable. So you're much better off essentially with a binary talking to, I don't know, libc or your kernel ABI, your binary interface. Because the minute you're speaking with the container C groups and all that stuff, these things are in flux right now. They're going to break. I want things to last. You know, what are those things in Greece that have lasted hundreds of years? The apocalypse. Sorry.
I mean, we've got plenty. We've got the Parthenon. We've got
the Pantheon. Yeah. I must apologize for
the Pantheon is in Italy, I think. Yeah.
Oh, okay, not the Pantheon.
Parthenon.
The other. Yeah,
I
think the British took some things. Hopefully, they'll give them back to you.
Yeah. We have a strict no political talk in our group, so
sorry.
let's stay out of that.
You can edit this part out.
No, we're not gonna edit anything. I think we've talked about a lot of stuff. I think the audience is gonna hear about a lot of new words today. So maybe we should end on a positive note and say that just start with Linux and things are gonna fall into place. Sure,
I mean, but Linux isn't the only operating system. Another good one to look at is maybe Plan 9 or BSD. I mean, anything open really. There's all sorts of things like, you know, Minix, Oasis, all sorts of things. Just trying to have fun.
Okay, I can see why BSD would be one of them. I like BSD from what I hear. They've got a very nice system with there, but I've never used BSD.
Yeah, the code is nice, and yeah. But anyway, just find something interesting, because it is a very overwhelming type of industry. But yeah, I'm happy to answer anyone's question, so do please ask them.
Okay, where can people reach you?
Henry at icky.fi. I almost pronounced my name incorrectly. That should be my email until the day I die, and then that will be my wife's, hopefully. And then I have a homepage, henry.icky.fi. You can find me on social media and all the rest of it.
I'm gonna add that. I'm gonna add both of them, both of the links in the GitHub page for this event. So cool. You can find it in the description of the video or in the comments right now.
Right. Thanks. Thanks, Yannis.
Can you give me one last suggestion? What distribution do you suggest for newbies? Please don't say
Whoa, that's a loaded one. I mean, if you want to learn the hard way, you should install Arch Linux. But for noobs,
I've got a counter argument.
For noobs. Maybe PlayStation 5? No, wait. Wait a minute. An operating system for noobs. Geez, I don't know. I'm an expert. Sorry.
I started with Manjaro in 2018, and from the moment I installed it, I was trying to find what they did to make Arch user-friendly. And I started building up my script to automate the Arch Linux installation. And it took me about a year until I was able to move to Arch. Now I was studying at the same time. I was a very newbie. Like, I didn't even know how to code at the time. I didn't know.
Yeah, I mean, it's not going to be easy. But you know, it's like I think the analogy about like a sharp knife, right? Like a sharp knife is not very user friendly, right? You can cut yourself with it, but once you learn how to handle the knife, then you can go and rob people. Then you can go and cut things effectively and do the job that you need to be. Needs to be done.
I have to say that, not to sound stupid, it took me 1 year because I was trying to get my total package count to less than 800.
Yeah.
So,
don't feel bad. This stuff takes time. Like, I remember going to my first year of university in England, and we started the class, and the guy was introducing Bash, I think, POSIX Shell, Unix, and he said, things probably are not going to click for you until maybe 2 years' time. And I was thinking to myself, what an idiot! Anyone can learn some of this stuff quickly. But it did honestly take about 2 years. And then I realized the beauty of Unix. Everything's a file, that everything's pretty simple. Everything is like, the concerns are very neat and well thought out. And the whole design of the operating system is amazing. It took me seriously 2 years. And of course, I'm always learning. There's always something to learn. So it's not like I'm like reached a plateau or something like that. I'm always learning. I'm always evolving, and that's the approach that you need to. So I love getting comments from people saying what I don't know, and then I go, okay, I'm gonna find out about it.
All right, Kai, thank you very much for being with me here. It felt more like an interview than co-hosting, but anyway, thanks a lot. Subscribe to Kai's channel. I've been watching him for 1.5 years, and I've learned a lot of stuff. In the beginning, I couldn't understand anything, but I was hearing a lot of new words, enough to make me look into them more. So anyway,
do ask questions after Googling the term first. Yeah, you got to do a little bit of homework, of course. But yeah. I'm great that you hopefully you continue to subscribe and that sort of stuff, and hopefully I can make content that will be of interest to you.
All right, thanks a lot, guys. Goodbye.
Bye, guys. See ya.
I'm back. I hope you enjoyed the talk with Kai. First of all, I would like to say that before we go to the Q&A, that I don't know if we have any people from abroad watching. I have created a couple of polls for the next shows, one of which has to do with the language that we're gonna make the shows in. Eleni, can you help me share the link I'm sending you right now, so people can visit our GitHub page, which is the second thing that I want to talk about right now. We've created an organization on GitHub where you can find our presentations, our past presentations, and also announcements or the content of future presentations when we make them public. And on top of the README file, you can see the two questions. So if you're okay with English, and the second one is what topics you want to hear about in the next events, about DevOps, of course. Now, with the help of Eleni, let's go and answer a few of the questions we've got so far, if we have any. Eleni?
Hi, Yannis. Thank you very much. The presentation was really good, and we are ready to move on to the questions. So, Jim asks us why SPAs are not ideal for continuous deployments.
Well, to be honest, the main reason I think that the main reason that Guy suggested not to use SPAs are because of the SEO optimizations. You can't really optimize your website for better discoverability in Google, for example. So things like an eShop, of course, can't be made in a single-page application. You should use something like Hugo or other tools to build static pages for you, static web pages. But it's not really mandatory. Also, I think that it would be very hard to test your code if you build SPAs instead of normal single-page, multi-page applications. But it's a personal preference, and it has to do with what you're designing. If your project is better suited for an SPA, for a single-page application, you should use that. I think I don't have anything else to say about it.
Okay, thank you very much. So, Adonis asks, can you define Ansible tool?
Ansible, yeah. Well, as Kai said at the end of the talk, you should do your homework before asking questions because we talked about a lot of new terms and tools. However, since I mentioned Ansible a few times, Ansible is a tool written in Python by Red Hat to automate configuration management, and locally you could use it as a server administrator, for example, to set up multiple servers at once instead of running a bash script or a Python script to every computer manually. You could run it with 100 computers or thousands of computers at a moment's notice with one click.
Okay, let's move on to the next question. Castellion wonders if it makes sense for someone who has only experience in university-related courses to venture into DevOps without any intermediate programming experience.
Yeah, I see classical sysadmin. Well, it depends. If you're working in as a system administrator in a company where you don't produce any software and you want to keep working in that sector, there isn't any point in learning DevOps. But if you want to dive into development yourself, or you want to or you're working at a company where they develop software, either dark matter developers where they make software for internal use, or even companies that sell software as a service, then you should probably learn a bit about DevOps, not only to help the developers or make your job easier, but maybe even get a raise. I don't know, depends on the company you're working on. Sorry. But yeah, it's a different industry. Like a system administration, for example, in a factory where they have a huge factory, doesn't have to learn DevOps.
Nice. So
I think that's all I have thought.
we have
One more thing I would like to show, because I forgot, is our GitHub page and show you a bit around our organization. So if you can make me full screen.
we have sorry, Yanis, we have a last question, and you can then.
Okay.
So Konstantinos asks why so many people are afraid of DevOps.
Konstantine, probably because it's a bit boring for developers to write testable code. It's not very easy to test, especially front ends with Python scripts, for example. Besides the automated tests that you add in your code, and in general, it may slow down your speed when it comes to developing, but it increases your speed when it comes to deploying your code. You have more. You have some trade-offs, and it's a new way to do things. I think, in my opinion, it's the way of the future. Every company that creates software that runs on the web is gonna, or even Android and iOS applications are gonna start using DevOps. So time will tell. I don't know.
Okay, thank you very much. Now you can show the GitHub page to the guys.
So this is my page on GitHub. You can find the links. The address is right there. You can find the links for the two straw polls that I've created. One is for the language. You can only click on one of the answers. And the other one is for my next presentation. You can give me a few ideas. I think I'm going to go with setting up a Linux workstation / home lab with automation. I'm probably going to write some Ansible scripts, Ansible playbooks from scratch to demonstrate. And maybe we can even do some live coding with live questions to automate specific parts. You could, let me show you our main page. This is our main page. The organization is called DSC, DASA Web, the same name for the repository. Here you can see our Discord server, where you can join by clicking on this box. Those are the links for each of our pages, depending on the subject. Presentations that weren't specific to one of those subjects are going to be added in here. For example, Ian's last presentation about Git is in here. And you can find more information about each specific event laid down here in the README. For example, you can find here my host, his YouTube channel, his website, his Twitter, and the blog post about microservices, where he mentioned in the talk is right here. If you click on event notes, I think I've added it. That's it. Now, thank you very much for watching my presentation. I hope I see you again here next time.
Thank you guys very much. We hope you enjoyed the event. Happy holidays. Stay safe. Καλά Χριστούγεννα. And we hope that we will see you next year.
Goodbye.
Thank you very much.